limited with this kind of skill set.
Of course.
And this is core to anything that has to do with software, data structures, and algorithm. Core.
Of
That is what differentiates
course.
a software engineer that knows what he's doing and somebody who just knows how to write code.
Exactly.
Mm. Nice
But,
one. So I'm with you. I would like to co-present at some point. So today
but
I'm a student today.
okay, okay. I'll put that. I'll put that in my book. I'll put that.
Okay. Okay.
Uh, no, the classes have been particularly challenging, but then,
No,
um,
it's okay. That's how it's not a walk in the park.
yeah, of course, I know that, right?
This is a prized skill set to
Mhm.
have anywhere in the world,
Sure.
you know. So anybody who is lucky to be in this setup, men should thank God every morning. Thank you. I just wanted to thank you in advance for
Thank you too.
having the initiative to even start in the first
Thank
place.
thank you, thank you. Those kind words means a lot. I mean, I'm getting some testimonials from people in the group already, and I mean, it has been helpful. Wow. Throughout once I started, I was like, oh,
Mm. I'm on a desktop. I'm working multitasking, so my camera is not up, but I believe subsequent. How long does it last? I can't hear you.
yeah, sorry about that. For some reason, my mic just
Went
stopped.
off.
Yeah,
Okay.
so I have to refresh. All right, it lasts for an hour, but the
Okay.
program
Fine.
will last for quite a long time. I initially, I mean, in the initial stages, I just wanted to do it for September, but I don't think it would be fair for the community to just do. This is about the end of September, and then we have we still have some parts to touch before we, get to the
Okay.
end of it.
Do
Yeah.
you have some kind of correct guide or plan?
Yes. Well, I've not released it to the group yet, but I actually, I actually had a plan, but I was reworking it because, first of all, this is the first time I'm going to be delivering this across audiences, and I had a lot of entry level, mid level, senior level, a lot of there's this large subset of developers I had to deal with. So I needed
Awesome.
to see the first few weeks and the first few courses how it's going before I
Okay.
worked on it. But for the next couple of classes, I already have that in set. But like today is like the last class for arrays. I
Okay.
mean, yeah. So once we
So
start touching,
you're dealing with fundamentals while you're teaching data structures and algorithms.
yeah,
You have
yeah,
to
I'm
fill the
dealing.
gap.
Yes,
Well,
I have to. Yes, I
okay,
have to
that's good.
because it is not it's like an uphill tax, but it's worth it.
Yes,
And
it
it's
is. Mm.
6 minutes already. So
Please go ahead.
without
Sorry
further
for.
ado, oh, no
Mm,
problem. I mean, we usually wait 5 minutes for people to come in. So
okay.
we are starting right away. Let me open this. All right. And Google. So today we'll translate into doing something a bit more difficult. More difficult. All right. I hope everyone can see my screen. Yep. So let's see, trapping rainwater. Yeah, I have this trapping rainwater lead code.
Mm,
So, like I promised last week, we are going to be solving this. And okay, the screen might not be as big as everybody wants it. So we can see here is a hard problem. This we are just using it to touch 2 pointers so that you can think of how to use 2 pointers in solving any and everything you have. So the question goes such: given a non-negative integer, given a non-negative integers. Okay, given n non-negative integers representing an elevation map where the width of each bar is 1. Compute how much water it can trap after raining. Right. So basically, we want to know say we are giving this input as an array. Of course, it's going to come in an array, and each of these is going to take a width of 1. So from the first one is 0. So 0, the width is 1. So it's going to move from 0 to 1. So the next element is 1 at 1. Next element is 0. So it's take the 1 point and go back to 0. Then the next element here is 2. So to take 1 point and increase to 2, next element is 1. Take 1 point, reduce to 1. Next element is 0. Take 1, reduce to 0. It's just like the width. The width is not imputed here. They just impute the height, but they also give the in the question, they say where the width of each bar is 1. So every of these bar, the width is 1. So we want to know how much water it can trap while raining. So assuming all this place is empty, if it rains, okay. If it rains, it's fills in these empty spaces. So we want to know how much water can be trapped.
I'll eat some other time.
How much water can be trapped? Hello, I can hear your voice over.
Sorry. Let me. How do I mute?
Okay, this is. I don't know if you're using your phone or this, but you see it at the bottom.
Okay, I've seen it. Okay,
yeah.
I've seen it.
Great. Thank you so much. So yeah, so we want to know, if it rains, it will fill in these empty spaces. So we want to know how much water it can trap, right? How much water it can trap. We are ignoring this space because of course there's another question here, but we are going to ask of constraint what will happen to the right and left boundary. In this case, from what I'm saying is that, let's see, constraint n is equals to height dot length. 1 is less than or equal to n, which is less than or equals to 2 raised to power 10. 0 is less than or equal to the first height, which is less than this. So we are assuming that the bounds of the left and right won't be counted, right? Because we don't know what is, if we are starting from 0, we don't know what is at the left, so we are not taking that. So we are going to start taking from the first element. So assuming this one, right? They've already done a pictorial version of this map, so it is as it is. So we want to know how much rainwater, because we are not taking the left bound. We don't want to think how much rainwater is here. This is just the line of the graph. We don't know if by the left there's a slope, a minus something, and then we can't trap water. We are not concerned about that. Same thing, we are not concerned about what is at this point. So the graph is already set. So if rain falls, this blue shaded region will be the rainwater that is trapped. So how can we solve for this? Now there are many solutions, right? And really, because of time, I really don't want us to add the different solution. There's the solution of O of n square. We've done that double loop. We don't want to do that here because of time. You shouldn't be using O of n square, like we said. There's using stacks, but of course we are still not going to undo stacks because we have not gotten into that data structure yet. There's one that is using dynamic programming. We are not going to use dynamic programming yet because, like we said, we've not treated those parts of the course yet. So we shouldn't be particularly concerned about that. But anyways, the one we are doing now is the most optimal solution because it's going to run in O of, I'll keep that and then I'll ask later, of course. What is going to run is going to be the most optimal solution. But then let's look at this and determine how we are going to solve it. Of course, we are going to use 2-pointer. So for instance, one wants to start solving this. We look at the first point, right? We look at the highest points. Now, ignoring this part is starting from 0. The highest point from the left is 1. We know that the rain is going to trap for, we are not really much concerned about the highest point because whatever is at the highest point, we can't get water. We can't get water to fill this empty space. We are considering the 2 highest points, but in the midst of the 2 highest points, we are considering the lower of the highest. So we have these points. This part will be where we determine if the rain falls. We are not looking much at the higher point, we are looking at the lower point. So if we are starting from here, we are going to look, okay, this is higher 1. Then if we are going down, we are supposed to calculate that area that is going to be covered. And since everything is of width 1, we are going to multiply 1 by whatever it is. So here is 1, then it goes to 0. So it's going to trap 1 times 1, 1 times 1 unit area of water. But here it goes up. Then when it goes up, you know that like anytime it increases, you are not expecting to trap any water. You only expect to trap water when it goes down, because it's creating an allow for water to be there, right? I don't really know if I'm explaining this that much, but then we are looking at when the slope goes down, and then once it goes down, we want to find the area, the difference between the point it was before to the point it is currently. And also we want to find for both ends, right? We want to start from here. I mean, it's going up, so we don't calculate. It goes, yeah, then it goes down, so we calculate. It goes up, we still don't calculate. It goes up again, no calculation. Then it comes down, we calculate. And of course, it comes down, down, and we continue calculating. But then the challenge we have is that, how do we tell if, for instance, this is coming down, this is coming down? So are we supposed to calculate, this should be 3, right? Are we supposed to calculate 3 times 1? No, because we don't know what is at the left. Because if we calculate 3, it doesn't fill the whole 3 space. It fills to 2, like 2 area. No, let's say it fills to the height of 2, not 3. So at this point, we also want to keep track of the left and the right. Then we see which one is lesser. Then the one that is lesser, we start, we calculate from that one down, because assuming we have these 2 points, right, the right and the left, I want to calculate for the area. It will be best to calculate from here, because the left is the one that will determine how much water it's going to hold. I mean, the lower point is the one that will determine how much water is going to hold, not the highest point, because the highest point, I mean, as much water is going to be, the water that is going to be held will be between the lower point to the higher point, not between the higher point to an arbitrary point, but it can't go higher than the lower of the 2 high points. So you are going to be considering the left point. Now, this is a little bit tricky, but we are going to dive into the solution right now. So of course, we are going to use 2 pointers. We are going to initialize 1 pointer at the left and initialize another one at the right. So in doing that, of course, like I said, we have to initialize 1 left, 1 right. So I want to come here and say int left is equals to 0. Int right is equals to height, which is the length, which is the array, right? Height dot length minus 1. Why are we using minus 1? Because of the index of array start from 0 to 1 less than the height we are dealing with. Then we also want to keep the maximum rainwater at the left point and the maximum rainwater at the right point. So we want to see the maximum point at the left and at the right while we are looping close, so that we're going to check the left and the right, which one is higher, then we calculate the area. But then we're going to do this int left max. I'll just call that left max, sorry, equals to 0. Int right max is equals to 0. But we are initializing it at 0, 0, because we don't know the height of any of these elements. Now we want to loop through this until when we have left equal to or less than right. So we want to start from here and loop from both ends till you get to the middle point, and then you stop, because that's how you're going to calculate it, right? So of course we are going to have a while loop. That's while left is less than or equal to right. Now, this is where the journey begins. What, like we said earlier, we want to check, okay, if left is greater than right, right? Do we loop from left to right or right to left? But we also want to loop knowing that the one we are looping through is going to be the lower of the 2 points. You get? We are going to look for the lower of the 2 points, right? So if we are looping from left or right, we are going to check if left is greater than right, then we are going to loop. So we are going to check if the height of left is less than the height of right, then we move left and calculate. But if the height of right is less than left, we move right and calculate. But let me just do this in code and see. So if height left is less than height right, it's less than height right, then we have our else statement. That's if right is less than left. So if left is less than right, we have to deal with left. But we are going to check now if left is less than the maximum left that we have. If it's less than the maximum left, we calculate. If it's not less than the maximum length, we just increment it to make it the maximum length. So, I mean, at this point, left is 0. Like I said, once it's going up, we are not calculating the area. We are only calculating when it's coming down. Because once it's coming down, it's already creating an halo, and it shows that this is an high point. We want to calculate that point below it. We can't calculate when it's going up because we can't tell how high it's going to, and then if it will tap rain at the highest point. But we know that once it comes down, we can trap rain at that level. But then why we are using left and right? Because what if it comes down at the left and it comes down at the right? Which point are you going to determine, okay, what's going to be the highest of these two? So you take the lower of the two and iterate through that. So here we are going to have if height of left is less than height of right, we are going to say if height of left is greater than left max. If it's greater than, we know that it actually moved upward. But if it's less than, it moved downward. And once it's greater than, we don't calculate, we just increment. We are going to say left max equals to height of left, right? Then we are going to have our else here. What if it is lower now? At that point, we are going to calculate. So we need to have a variable that we store the water that is trapped. So let's call that one int trapped water. Let me trapped. I think trapped as a double. Trapped water is equals to 0. Of course, we are starting from there. So we are going to say trapped water equals to, whatever the old digit was, plus now. What are we checking? We also want to check the difference between the current level and the previous maximum level. I don't know if you're getting. That's what we want to check, because we don't want to, if we check from year to year, we are checking the difference between 1 and where it dropped to. I don't know if you get. So that's what we are going to do. We are going to have trapped water equals to left max minus height left. And once we are done with this, we actually increment left. So we are going to, here we are saying left max.
Do you want to leave line 14 without parentheses to?
Oh, there's a parenthesis here.
Line 14.
Yeah, there's a parenthesis here.
No, I mean, what do you? Okay.
Okay, sorry. Oh, I was talking about semicolon. What was your question again?
Do you want to leave left max minus height like this, or you want to put it in a parenthesis?
Oh, so so that is
you can force the sequence.
No, but it's plus and minus, so you're not really forcing. If it was multiplication and addition, yeah.
It's okay the way you. That's what you want to achieve.
Yes.
Evaluate from left to right.
Pardon?
They have the same.
Addition. Yeah, they have the same order. Addition and minus, they have the same order.
So it will process from left to.
Is it left to right or right to left?
If they have the same order, addition should be left to right.
Left to right.
No, left is from trapped water plus left.
Actually, it's I evaluate from right to left.
Is it right to left? Okay,
yeah,
for the same.
Yes.
Okay, go ahead, please.
Yeah. So
Sorry.
it's right to left. So the bracket won't matter in that case. Even if it's evaluating from left to right, the bracket at the same time won't still matter, right? So
that's true.
Let's go here. So we want to do the same thing for the right elements. Now we are incrementing left because once we are done with the element at this index, we want to move past it and not touch it again because we are done with it. So we are going to calculate 1, which is the, so we are going to start from 0, right? 0 is the maximum. We are going to check, is 0 greater than 1? It's not, so it's less than. We are going to do that. Yeah, we are going to move 0, then we have 1, then 1 at this point will now be the highest point for left, the left max. So we are going to check the next point for left, right? If, which is 0, is, so we are going to check if left is less than this thing, then we are going to do, of course, 1 is greater than 1. At that point, it won't matter which one you moved, right? But I mean, I would have used equal to or less than, but it won't matter which one you move. So it's going to check for 1 and 0. So 1 and 0, 1 is higher, so it's going to be trap total plus 1 because this is what you're going to add, right? Because once you're going down, like I said, you calculate the space that it went down with. So calculating, for instance, in this case where you have 2, it went down by 1, so you are going to calculate 1 because you are going to also have where you calculate this. You are not sure if it goes down beyond this, so you're going to calculate it that way. All right, so now let's see. I mean, this logic works for left. Now let's see how it goes for right. I would have copied and pasted, but it's almost the same thing. We are going to check if height of right, is greater than right max. Then we are going to say right max is equals to height of right. Otherwise, of course, this is not that. Otherwise, trap total is equals to trap total plus right max minus height of right. And then, of course, I will now increase right plus plus. So at this stage, we should have our solution right. But let's see if we return it and it gives us the right answer. So let's return. Right. So we have this. So let me just run this code for now and see whether we have the right answer.
Line 11.
Okay, line 11, left. What's the error there?
The left X instead of LF, LEFT.
Oh, thank you. So let's run this again. Okay, index 12 out of bound. So we are getting an index out of bound. So yeah, we are not supposed to increase right, we are supposed to decrease it, right? So here we should have right minus minus. Let's run this.
Wait, so we don't understand how that happened, but go ahead.
Yeah, I mean, we have an accepted solution. Now let me explain the code bit by bit.
Wait, scroll down. Let's see the accepted solution. Okay, yeah, so it worked for that test.
Yeah, so I mean, let's submit and see if it works for that test. Oh, I've worked on this thing before. But that was 2021. All right.
Okay.
Okay, so we have our solution. 1 milliseconds. Wow, faster than 99.9. Like I said, this is the most optimal solution with the least amount of memory.
Okay.
Oh, I was getting 188 milliseconds previously. I was using Kotlin. Now you see, I was using Kotlin then. When I mean 1,800, that's a lot of time. Anyways, so this is the accepted answer. Now I will get at this point that we are going to think, how is this thing working? What exactly happened here? So we are going to break it down into code. So let me go to this place. Wow, what just happened? Oh, dear. Sorry, let me just attend to people online. I think they are saying they couldn't be admitted into the meeting. I put an automated, there's a Google plugin that's automated for admitting people into meeting, but the time I left and came back, I found that I stopped. I was seeing my phone ringing and I didn't know what it is. So let me say, please retry. So sorry about that. I mean, I should be expecting them now. Please just give me a minute, right? I just want to ensure when I'm explaining it, at least a good number of them are here that actually try to join today, because it wouldn't be fair.
It's all right. There's no problem.
Yeah.
Lovett Duke and David Odejobi. Hi.
Hi, sir. Good evening or good morning.
Yeah, it's morning for them. It's in the
No,
PST time zone.
no, we have entered afternoon. It's
Oh,
1:29 p.m.
oh,
Okay.
Mm.
all right. So now it's automated.
Mm.
Let me. I mean, if did it join? Did anyone join? Okay.
They will.
Okay, we have 5 people already. All right. So sorry. All right. Oladapo. Okay. I mean, all right. I have this sheet here. So let me just copy my question here and then fine. So let me copy this solution, because this solution, seriously, the first time I attempted doing this and I learned of it, I was like, what just happened there? I didn't understand a bit of what happened. I won't even lie. It looks save images, real water. Give me a minute. Let me where's the insert function here? To insert image, upload from computer, download. All right. Start presenting again. Hi, hope you can see my screen now. All right, thank you, Peter. Thank you. I'm so sorry. I mean, I've explained what happened. Right. There's this plugin I have that auto admits people on, so I don't have to switch here to admit. It's kind of distracting. So I add the plugin. I have to approve the plugin to admit people automatically on every meeting I create. And then for some reason, I had to restart the meeting. So I didn't recall admitting people again, and then so bad. I'm so sorry. But then we've not gone far. Actually, we've gone far. We've just solved the question for today, but we are going to take the next few minutes to explain it in depth, because it's a little bit confusing. A solution. So welcome Moses, welcome Peter, welcome Roquip, and welcome Oladepo. So we have this lead code problem. Given n non-negative integers representing an elevation map, goes up and come down, where the width of each bar is 1, compute how much water it can trap after raining. So we have this is what they will give you, an array of this. So if you implement this and you get it into a bar, you have something like this, where it starts as 0, goes to 1, then come back to 0. But they say the width of each bar is 1. So this is the height, this is the width. You know how we did graph in school. So the x difference of each bar is 1. So from 0 to 1, you have a width of 1. So in this case, they did this, and we spoke about the left and the right boundaries. So we don't want to keep the left and the right boundaries, because we don't know what is at the left. So we can't start calculating from the edges of the boundary. We can't start calculating outside the edges of the boundary that was given to us. So for here, we are not calculating. I mean, if rain falls here, we are going to ignore if here it's maybe if whatever is at the right of this. So we can't trap it. So we just ignore it. Same thing, we are going to ignore whatever is at the right of this, whatever is at the left of this. So this solution is just working in such a way that you find the how much water this can trap, right? Because it's going to create some trenches, hollow, some pits to store water. But then since it's an elevation map, some places are going to be higher than some places. And how are you going to tell how much water is going to store? Then, like I said in the previous solution, because you have some places higher than some places, right? You are not going to take the highest points to calculate the water that is going to solve. You are going to take very high points. Then you are going to take the list of the higher points to determine, because if you have this point which is at 1 and this point which is at 2, you can't calculate. This point is at 3, this point is at 2. You can't calculate for this point because it's higher, and then there's no bound. There's no bound. If rain falls over here, it's going to spill over to this side. If there's any, if it can't trap us, whatever is going to determine how much water is going to trap is going to be the list of the 2 high points, right? So if you are taking 2 points, but then we said we are going to use 2 pointers and we are going to look from left to right. From left to right and right to left, depending on which one is higher, right? We want to check, and we are only calculating for the amount of water it traps when each of these points goes down. We are not calculating when it goes up, because at this point, if it goes up, we are not going to say, oh, how much water is storing. It's once it's up and it comes down, we are saying, okay, it's going to create an halo for water to come in. For instance, when one goes up from 0, we can't tell, because like I said, we are ignoring the left bound because we are not giving whatever it is there. But then once it comes down, it creates a space to trap water. So from here to here, it's space to trap water. But how do we determine if, this place is either higher or lower? Because we can get it go from here to here, then we can get it even go a bit lower. How do we check that? That's why we are going to test for left and right. Since we are getting 2 pointers, back to the this. So in this case, right, let me copy this code. So that I will explain at this point. So at this point, since we are getting 2 pointers, we want to check the list of them, because we have height left. We are checking if height left is less than the height right. Now height is the array they give us. We are taking the left index. We are starting from where left is 0 and where right equals to the length of the array minus 1. So at this point, we are checking if left is less than right. We want to deal with left. Why? Because at this point, left is 1. If at this point, height maybe is 3, we know that no matter how deep left go, it's going to store as much water as deep as it goes, because we are not going to take right. If left is greater than right, we know that whatever is between left and right can be trapped. I don't know if you get, how do I put it? If there's a container that has the left points lower than the right points, you are going to check, you are going to know that anything lower than the left points is going to be a space for the water to trap, because you know that there's also something that is already higher than the left points. So you know that no matter how deep it goes, it's still going to come up. So the same thing, if the right was lower than the left, you know that no matter how deep it goes, it's still going to come to the left. So you are going to leave the left alone and calculate from the right, because it's the minimum. You are calculating all the spaces that can trap water between right till you get to a point maybe left is now higher than right. So you just do it like that. So given these points now, if we start from here, we are going to calculate if this is greater than this. If it's less than or the same, we continue what we are doing. If it's less than, because we know that whatever goes inside here is still going to come up to this point. So we calculate from this point. Then we move to this point. Is this higher than this? Yes, sure. Then we are going to take from left and right, because we know that since it's higher, it can only go up to this and not actually lower. That's amount of water it can trap. Oh, am I explaining this right? Are you understanding me? Is it clear? Hello.
Is it possible to use diagram that you draw
Okay.
on paint or something to show the movement, how the movement happens?
Whiteboarding, start a new whiteboard. All right. Everybody could have access to the whiteboard right now. So let's use a pen. So we have this container of water. This might be a container, but let's take this up to this point, right? Then inside we have a blockade that is like this. And we have these points, right? Then inside we also have another stuff that is like this. Now imagine these points. No matter how much rain falls inside here, it's not going to take the full width of this because from there's going to be a line here. Now there's a blockage here, right? So everything here can be stored because there's no point holding it. Let me just undo that. So you see, we can't trap the water that's from here to here. Why? Because there's a lower point here that is going to change the calculation. So if here was a 5 and here was a 4, we can use 5 times 4 to study the water. But then we don't know if there's anything inside that is going to take less of the space, right? So we are going to assume that we have to look through every element and check. So I'm going to use an eraser to clean these points, you know. So in this case, we have something that looks like this. Yeah, I mean, this should work. So it has to be something that looks like this. So if rain falls, the rain will fill. Now I can't paint with my distance, but the rain will fill from this point to this point down. Then the rain will also fill from this point to this point because this is the higher point. No water can stay from here to this place, you know, because it can't hold the water, right? I don't know if that's clear, because there's no left container that is corresponding to that place that can hold the water. So the water is going to be only trapped for this, you know, let me see if I could shade. And that's, the water can only be trapped for these shaded points. These are the only places that can hold water. Then of course, this place, everything here can hold water because there's no blockage here. So, but you can't have water at this above region because there's nothing that will hold the water. And same, you can't have water here because the tank doesn't have a corresponding endpoint to hold it. I don't know if that's clear. So the water can only be from here to here, here to here, and here to here because it can hold that way.
That makes sense.
Yeah, that makes sense. Thank you so much. All right. So in that case, if we are to look through this, if we take this as the left points, L, these are the right points. If we find out that the left point is actually higher than the right point, we want to deal with the lower of the two. Why? Because assuming there was no blockage inside, right, we are going to have the lowest points responsible for how much water can be shared. I don't know if you get, because if you say the high point, the water above this place can't be stored because the highest point the water can go would be the lowest of the two highest points or the 2 points you have. I don't know if you get. So if you have the left point higher than the right point, then the left point will determine how much water is going to store, not actually the right point, because anything that is higher than the left point won't be stored because it's like a container. Say you have, let me undo this. Say in this case, you have something like this. You have a container like this. This one will represent this. Then you also taking this one, you have a container like this. These parts now, all these points will represent this, right? You have a container like this. So the water can only be to this point, right? Then same here, because water can't enter this because it's an elevation. We are going to take from here and here, which will look something like this. So at this point, no matter how high the highest point is, it can't store water because this point will determine how much water is stored. Any water that comes above this point will actually overflow to the left. Any water that comes above this point will actually overflow here. Any water that comes above this point will actually overflow here. Now, I'm using a container to share it, but it's not like a container per se, because if you have a tank, it's going to store as much water that's inside here, but you might know this area. But then we are just using elevation maps. This point here can't store any water. So between this point and this point, is this point that will determine how much water that we store, not this point. So between 2 points, we are taking the least the least high point or the lowest of the 2 points to determine how much water will be stored between those 2 points. So at any point in time in our program, we are only looking at 2 points and nothing more, because we can't take from the extreme right and the extreme left, because we can't tell if how many points are in between. But why are we going to use that in our code? Because if let's have another table, right? Let's have another. Okay, I can't expand this. So yeah, so if we have something like this, let's say this is a graph. If we have something like this, so it goes down, right? Then we have something like this. Now, assuming we are ignoring these parts because we don't want to care about anything at the left index, then we have something like this. Let me make this higher. If we start at this point, which is a 1, then we come to this point. Okay, let's ignore the rectangle because it might make it look a bit confusing. Let's say we have this, and we have 1 point. Now I will represent this rectangle as something like this, represent the higher rectangle as something like this, represent this third one as something, higher than the 2. So the rainwater we are going to store, ignoring the left and the right, is going to be water from here to here and water from here to here. I mean, that will make sense, obviously, because these are just sticks that will store water, right? Any water that goes above this point in between this space will overflow to this place. And because we are not concerned about what is at the right and what's at the left, so we are going to ignore whatever it is here. And same thing, any water that comes beyond this point, as far as these 2 points are considered, we go and fall over here. So this will determine how much water it will stay. And this one, because it's the least between these 2 points, to determine how much water is saved. Does it make sense?
Yes.
All right, great. All right, great. So now that we have said, now why I didn't choose these things is because this part will be making it look confusing. They said every part has width of 1, so we just take this as representing 1 stick. Same thing if we are to go to our code here. So instead of this width, we are taking it at 1 stick here, but then this pictorial representation is, how it means, but then that way. So now, taking a look at this, let me erase this guy. Let me erase this guy. Erase. So, of course, erase this point too because we are using graphical representation. So now this is how it will look like. So now let's draw a even more concrete map. We have our straight line here. We have 1 point 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 here. Maybe something like this. So the water that will be stored will be all this. Let me make this one a bit higher. Maybe this point. Make this one a bit higher too. This point. This point. And that's it. So in this case, let's make it like this. Yeah, this stick will also determine what is saved. So yeah, we have this. So if in calculating the rainwater, we are going to take 2 points. Point A, this should be point A, or point left. This will be point right. So we are going to start with the 2. So let's assume point left is of elevation 2. Point right is of elevation 1. Then let's assume this is of elevation, let me make it 5. Then here is 4. Yeah, here is 4, sorry. Sorry, that's not, trying to make this number progressive. Here is 3, here is 4. So this point is a 2, this point is a 5, this point is a 3, this point is a 4, this point is a 1. So how does our algorithm do? It will take the first, it will initialize at the extreme left and the extreme right. So it's going to check. Sorry. This is a bit so tiny. Now how do I do this? Anyways, it's going to check if left is less than, right? That's if this point is less than this point. Why are we checking if it's less than? Because we know that the lower point will determine it. So at this point, we are not concerned about what is at the center. We are only concerned about these two. We know that whatever the lower point is, it will always climb to the higher point, right? To always climb to the higher point. So we want to start calculating from the lower point. But whatever the high point is, we are not very certain that it will, drop to the lower point, because it's the lower point that determines the height of the water. So at this point, we are going to check 2 and 1. We are going to see 1 is lesser. So we are going to deal with 1. So we are going to check the next point from 1. So the next point at this point is 4. So we are going to check if this next point is less than this. It is not less than. So we are going to initialize the left max of right to be 4. Then we are going to go through the next loop. We are going to check 4 and 2. Which one is lesser? 2 is lesser. So we are going to check the next from 2, because we are taking the lower point, which will be 5. Is 5 less than 2? So this will be R max. Then left max now will be, left max was initially 2, now it will be 5, right? Then we are going to calculate 5 and 4. Which one is lower? 4 is of course lower. So we want to calculate the distance between the next point of 4. So it will be 3. So at that point, we are going to get our area in that sense to be 4 minus 3, which is 1. So the area will be 1. But then this is just like an high level stuff, but it's going to drop lower because it's going to calculate 4 and 3. So the area now will be 1. Actually 3 anyways. I'm sorry, I'm not explaining this correctly. I am not explaining this correctly. 2 and 5, 2 is lesser. So it's going to store as much water from 2 to 5. So come on, I'm not explaining this right. I am not explaining this right. Sorry about that. So these two, how it will make sense is that we are considering this empty space. We are considering this space to this space. So it's going to drop from 2 to 0 to 5, from 5 to 0 to 3 and all that. So left max equals to 5.
Can we organize the screen in such a way that we would see your code and your diagram at the same time?
Yeah. I'm thinking how best to do that. Close document outline.
You can, your diagram can just be a thin rectangle on the top.
Something
by
like
the side.
This. Okay, yeah. So why left is less than max, left is 0, right is this. If the height of left is less than the height of right, so right, it is not less than, so we take right. So we go to this else statement. Then we say if height of right is greater than right, the max right. At the first point, the max right and max left is 0, 0. Yeah. So if right max is if this height now, which is 1, is greater than that one, so we have the height 1 is greater than that, so we are going to say this height now is 1. The max, right max now will be 1, right? So we are going to move to the next one. So right max is 1, so we have moved to actually 4, because we are going to right minus to 4 now. Then we are going to check, is the height at left less than the height at right? Yeah, the height at left is 2. The height at right is 4. Yeah, we are going to find that is true. Then we are going to check, is left max, is the height at this left greater than left max? Of course, it initially starts at 0. If it is greater, we are going to make this 2 the left max. So we are going to have, at the first point, we are going to have 2 here, and we are going to have 1 here. So next thing we are going to look, of course, we are only doing this else if the height is less than, right? If it is going down, that's when we calculate the area. So, where are we? So let me just be imputing this as we go. So we are going to start with right max, which is 1. Left max, then let's do left, right too, so that it will make sense. Right will be at 1, left will be at 2. Right max is at 1, left max is still at 0. The first iteration. Then the next iteration, it will check is the height at left less than the height at right. The height at left is 2. The height at right now will now be, since 1 has increased, will now be 4. Right. So we are going to check, is it height at right, of course. Is it less than 2 is less than 4? So yes. So we are going to come into this loop. If height at left is greater than left max, whatever left max was 0. Height at left is 2. So we now update left max to be the height at left. So here we have 2. Right max is still 1. Left is still now left will increase by 1. So left plus plus left will now go to where left is cos 5. Right will remain the same because we already touched right. Then we are going to look through again. Is height at left, which is 5 now, less than height at right? What was height at right? Height at right now is at this point it should be 4, right? Sorry, this point is 4 because we actually increased right at the first iteration, so 4. So is height at left less than height at right? Height at left is 5. Height at right is 4. So it's not less. So we come here. We will now check if height at right is greater than right max. What is right max? 1. We now update it to 1 and keep going. Oh my God, this my explanation is going nowhere. Okay, so now this is the challenging part in it. Left max is 0. Let me just I'll do this in the code so that it will be easier to make do. So at any point we want to print out system.out.print line left is plus height at left plus right is height at right plus left max is plus left max plus right max is plus right max. I want to print it out inside. Did someone say something? Which of the loop? So not there. So let's run this instead. All right. Left is 0, right is 1. Left max is 0. Can I copy this? No, I don't think this at this point. This here. All right, then let me copy the array itself. It should do the trick. So initially left index and right index. Right is height of right, okay, yeah. Okay, so left is at 0, right is at 1 for the first iteration. The max of left and right is 0, 0, but in the next iteration, left actually increase. Why did left increase? Because 0 at this point is less than this, so we are treating 0. So we are going to check our code. Oh dear Lord, this code here, this code here. So if left is less than right, so at this point 0 is less than 1, then we are going to check if height left is greater than left max, but left max initially was 0. So we are going to we are going to make left max equals to height at left, which is 0. If height at left is greater than left max equals to height at left, but this time height at left is equals to left max. So we are going to trap total equals to trap total plus left max minus height at left. So trap total will be 0 plus 0, which is 0. Then left max plus plus, and left plus plus. So we are going to increase to when left equals to 1 in the next loop. So that is what we have here. So same thing with the code here. If height at left is less than height at right, but here 1 is equals to 1, so it's going to do whatever it is in the right place. But imagine this was right. If height at right is greater than the max at right, which is 0, we are going to increase, but max at right is 0, 0. So now we are going to increase max right to 1 and move max right to 2 in the next iteration. So here we have it. Right is 2 here. So we are going to check if height at left is less than height at right. Height at left is 1. Height at right now will be 2, right? So it's going to be less than. Is height at left greater than left max? What was left max before is 0. So yes, they make height at left 2. Oh. Okay, now let's do it this way. Is everybody following? I don't think it. Is everybody following at this point?
It may help if.
Pardon?
Yes, we are following.
We're following.
We're following real good.
Okay. I just felt like the explanation is.
I know you need responses.
Yeah, I mean, like I said, this is a very complex solution, right? And I'm trying to explain.
As you're explaining, Peter.
Yes.
Just put the array close to each iteration.
Oh yeah, I should be
instead of scrolling up and down. Copy and put it so that we can associate. You can relate the changes that are going on with what.
Okay. So at this point, this is what the array is at this point. And at this point, this is what the array should be. We have touched this, so we are removing this from our array. So at this point now, since we have incremented this thing, we have removed this from the first increment, then we have also removed this. So I think maybe this way it will be better. So where was I? Yeah. So it's checking left equals to 1, right is equals to 2, left max is 0, right max is 1. So we are going to check left is equals to 1, right. Is height at left less than height at right? Yes, it's true. Is height at left, which is still this, greater than left max? What is left max? 0. So height at left is equal. So the next time left max will now be equals to height at left, which is equals to 1. So I will take that. Then of course it will ignore this and increase left by 1. So left will come to this 0 here. So from here, let it go to the next line. I also want to be copying and pasting this because it helps. Right? So at this point, we are done with this one. So I'm going to remove it from the array so that it looks easier. We are still where we are. So now left is 0. Right is 2. Right is 2. Left max is 1, which we have removed from the array. Right max is also 1, which we have removed from the array. So at this point, is height at left less than height at right? Is 0 less than 2?
Yes.
Yes. So it's going to check is height at left, which is 0, greater than left max. We already have left max to be 1. So we know that it's not greater. So we have trapped water is equals to trapped water plus left max minus height. So left max is 1. height at left is 0. So trap total will now be 1. I think maybe I should also do this in the code. Sorry. Plus trapped water plus trapped water. Yeah, at this point, this should make it easier to understand because we are also calculating for trapped water. So let me go back here and clear all this. Yeah, this should do. So it's here. Come on. So this. Anyways, let me leave it like this because I don't want to be editing over editing. So we start from this, right? So we are going to say left is equals to 0, right equals to 1. Our code is this. Our code is this. So we are going to check is height at left 0 less than height at right, which is 1. Yes, height at left is equals to the. Then we are going to say is height at left greater than left max? Is 0. Left max is initially 0. So 0 is not greater than 0. So it's going to be trap total equals to trap total plus left max minus height at left. Left max here is 0. Height at left is 0. So trap total, which is 0 plus 0 plus 0, everything with 0. And left will increase by 1. So we get here where left is now equals to 1. Since left has increased by 1, but right still remain the same. Right. So we are going to copy this, put it over this. Put the space, copy this too. Okay. So of course we have done away with the 0 because we have incremented in this previous one. So now it's going to check height at left is less than height at right. Is 1 less than 1? No. So we are going to actually do the else in this statement, which is this. So in this case, we are going to do else this, right? So let me take this out. So it's height at right 1 greater than right max. Right max is initially 0. Yes, it's greater than. So we just make right max equals to height at right, which is 1. So once we do that, we decrease right. So we are going to do away with this in the next iteration. So once we come here, we do away with this, right? And we have our same loop. So at this point, is height at left, which is 1, less than height at right, which is 2. Yes, 1 is less than 2. So we are going to say if height at left, which is 1, is greater than left max, and our left max initially is 0. So 1 is greater than 0. So we are going to make left max equals to height at left, which is 1. Then we are going to increase this thing. So we are going to have this array minus this one here. So we are going to have it like this. We are still going to check for this same if statement. So yeah. So left was 0. So we are going to check is height at left, which is 0, less than height at right. Height at right is 2. So yeah, 0 is less than 2. So we are going to check if height at left is greater than left max. 0 now is not greater than left max, which was 1. So we have trap total equals to trap total, which is 0, plus left max, which is 1, minus height at left, which is 0. So trap total will be 1. So you see it in this place here that it has updated. I don't know if you are following. I believe you see here that trap total, this code gets executed and trap total is 1, and we are dealt with this 0 because now we are saying left plus plus. So we are going to remove this and have this here. So since we're having that, let me copy this full code. Let me copy the if else. So yeah, we have we have it here. We have dealt with the 0, so we move it. So now let's do the if statement again. So we are going to check is height at left, which is now 2, less than height at right 2. So they are both equal. So we are going to ignore everything from here to here. So we are going to do this else. So we are going to say if height at right, which is 2, is greater than right max. Height at right is 2. Is it greater than right max? Yes, right max is 1. So yes, so we are going to make right max is equals to this one here, height at right. Then we are going to decrease right again. So we are going to have this, but now we are done with this one. So we remove this one from our array. So we are going to have this, right? Copy highlighting, I code. So we are going to copy this again. So at this point, is height at left 2 less than height at right 1? No, it is not less than. So we are not going to do everything from here to here. We are going to the if statement, to this else statement. So if height at right, which is 1, is greater than right max, what is right max 2? So height at right is not greater. So we are going to ignore this and go to the else. So we have trap total will be equals to trap total, which is initially 1, plus right max, which is 2, minus height at right, which is 1. So 2 minus 1 is 1, plus 1 will now make it 2. So at this point, we have 2. So since we are dealt with right, we are going to decrease again and come to this point. So our array size is going to change again. So we are going to remove 1. So we have this. Let me take this down. We have this. So we are checking. Left is okay. We have removed whatever was in the previous one, right? 1. So here we are going to check is height at left 2 less than height at right 2. So 2 is not less than 2. So we ignore everything here and do this. If height at right, which is 2, greater than right max is 2. So it's not greater than. So we are going to have trap total equals to trap total plus right max, which is 2, minus height at right, which is 2. So 2 minus 2 is 0. So trap total, which is 2, plus 0 will still remain 2. So we have this. But at this time, we have dealt with this 2 in the right. So we have to remove it and move a bit to the left. I'm going to remove this 2. Copy this code again. So at this point, I want this to go to a new line. At this point, we remove the 2. Is height at left 2 less than height at right? Yes, 2 is less than 3. So we are going to do everything here. So now we are going to check is height at left 2 greater than left max. Left max is 1. So yes, it's greater than, right? So since it's greater than, we increase left max to become height at left, which is 2. And then we remove this from our equation. We are not doing this because we are adding. So we are not doing this. We are just doing left max. We update left max and increase the pointer. So we are going to have this here. 2. The trap total still remain the same if you see it 2 here. So our loop again. And onto a new line again. So now we are going to check is height at left less than height at right. Height at left here is 1. Is it less than this? Yes. So we are going to do this. If height at left is greater than left max is 2. Height at left is 1. So it's not greater than. So we do else. So we have to have trap total, which at this point is 2. So trap total equals to 2 plus left max, which is 2, minus height at left, which is 1. So 2 minus 1 is 1. 1 plus this will be 3. So trap total will be 3. So we have it here. So since we have done with this one, we increase left and remove this one from our equation. So we go here and we do this and we copy this and we paste it here. And we do this. So now we are going to check. Height at left is 0. Is it less than height at right? Is 3. Yes, it's true. So we are doing this. Is height at left greater than left max? 0 is not greater than left max, which is 2. So is not greater. So we do this one, which is trap water. Trap water now is 3. So trap water equals to 3 plus left max. What is left max? Left max is 2 minus height at left, 0. So 2 minus 0 is 2 plus 3 will be 5. So we have our 5 here. So, and we are done with this 0. So we increment. So we come here, put it, we take this out, then we do our if statement. So yeah, we are here. So we are going to check. Is height at left less than height at right? One is less than 3. Yeah, true. So we are going to check if height at left is greater than left max. Left max is 2, so it's not greater than. So we do trap total, which is 5. So trap total equals to 5 plus left max, which is 2, minus height at left, which is 1. 2 minus 1 is 1. 1 plus 5 is 6. So we are going to remove this one, and we are going to be left with one element in the array, right? So 3. And remember our loop. Our loop says, I don't want to scroll there so that I don't keep. So let me just go here. Our loop says while left is less than or equal to right. You know. So we are going to do less than or equal to. So now we have 3. Left left now is equals to right. So we are going to say carry this our same code. At this point, of course, something might update or something might not. Let's see. We have to run for all. So we are going to say height at left is less than height at right. No, they are equal to. So we have else. Height at right now will now be greater than. We now check is height at right greater than right max. Right max is 2. Yes, if it's greater than 2, then we make right max 3. So once we make it 3, we are not adding this thing, we make left. So we go back to our loop, we say while it is less than. At this point, right now, we will now be less than left. So we don't print anything. So we just return trap total. Is that understood? Did we follow? Any questions? Is there any questions? Anyways, I mean, okay, I just joined from here. I mean, the document will be ready after now, and the video will be ready after now. Though I will cut it to the point that it will be clear. But like I said, it's quite a difficult one, but it takes some ways to solve it. There are other ways to solve it, including dynamic programming. We will do this in 2D graphs, 2D arrays and graphs, stacks. This is a data structure on its own. Then we also have the way of solving it, which is double loop. This will give O of n square. O of n square. So, I mean, this will take, memory will be O of n, time will be O of n. Same thing with this. So like I said, this is the most optimal solution, right? Double loop is O of n square, which is a terrible solution. But then let's go through why this is the most optimal solution. We comment this out. The time complexity of this is O of 1. But is there any question while we go on? Is it clear?
Not yet. You did a good job. It's challenging, but it's clear from how you.
I mean, the video will be out so you can watch again and again. I mean, maybe the guy Andrew from the course might even do he can jump at me, but like I said, once you get to some of these complex questions, you really have to sit and really think it through. Yeah. So off and off and off and so who can tell me what's the time complexity of this loop? Time complexity of this loop, this while loop.
O1.
O of 1.
Oh, no, sorry. Oh, man.
Great. O of n. It's actually O of n over 2 because left over right and right. We said we remove constant, which is going to be O of n. Because everything here is going to, this statement we run in O of 1, O of 1, this thing is O of 1, all these things. We are not doing any loop inside. O of 1, O of 1, O of 1, O of 1, O of 1. Of course, this is a return statement O of 1. So it's not a double loop. So I mean, this is the best solution that can be gotten right.
Okay, you said it's O of n over 2 because you're processing from both ends.
Left to right, yeah. So you are going to have the array at, they are going to meet at a center point,
The
right?
single, yes, yeah.
Yes. But then, like we said in the rules of this thing, once you have O of n over 2, O of n over 100, it returns to O of n. No matter what, you drop all the constants. 2 is a constant, so it's assumed as O of n over 1, because if you have an array of size 2 million, 2 will not change the code. Dividing it by 2 will not change it that much, right? So that's where we are here. So we have O of 1 plus 1 plus 1 plus 1 plus 1 plus n. So everything is O of n plus 1 plus 1 plus 1 plus 1, which is O of n plus 5, which we turn to O of n. So like I said, this is like the optimal solution. I will send this also the link to the group so that maybe you can try it. You can try it in Python, you can try it in Java, you can try it in JavaScript. But after this class, I will send it. And yeah, like I said, it's a technical one. But once you practice and practice, you can even refer to the video. I will make sure the video is cut to the beats, and then we can undo it. So please, I want to know, okay, I will ask that in the group. Do we continue with arrays? Do we take some questions with array, or we move to linked list for next class? So the class is open. I mean, I would assume the class for today is ended because
Peter, I would think we should still touch array.
Okay.
I think.
Okay, noted. All right. Okay, then in any case, at this point, right, this class is over. I will send this video to the group.
Are you open to take questions?
Challenges?
Yes, that you solve in subsequent class.
Yes, I'm open. Maybe I will do that tomorrow. So if you have your question, bring it. But then, how do I choose the question to take? I will. No,
we can send to you before the class. Then you now.
Oh yeah. That would be perfect.
So you can plan your time and everything.
Okay. For everybody to know, that's what I initially even had in mind. Right? You just send your question, but then, like I said, from the form feedback, I found out that I might need to start teaching some of the basics and explain to it, because somebody might go and dig up one graph question and send it to me, and then if you don't understand the basic, even if I explain from now to tomorrow, it's graph. Like when we talk about dynamic programming, that's where graphs come in. Dynamic programming is something else, but we are going to touch that subsequently. So yes, I'm open to questions. So maybe I will do that for the next 1-2 weeks before we touch linked list. But my challenge but let's try and see how that is. Please, questions on only arrays. But at this point, I would love to end the. Okay, I'm no longer sharing.
You want to end the recording?
Yeah, no. I keep the recording for a while. I thought I was sharing. I wanted to stop sharing. But let me thank everybody for coming. Thank you, Davey. Thank you, Faith. Thank you, Emmanuel. Emmanuel is one of my trusted assistants. Emmanuel. Thank you, Lovett. Thank you, Moses Wisdom. Thank you, Peter Eneche. That's me. Thank you, Peter Onipe. Thank you,
sir.
Thank you, Wisdom. I know Wisdom, right? Moses Wisdom.
Yeah.
Thank you, Roquip. Thank you, Mora. Yeah, you guys are highly welcome.
Thank you, Peter.
Yeah, so sorry this class took longer than expected. At this point, I would end it and then be open to question for the next 1 or 2 weeks, and then we'll know how we'll go from there. So
it's all right. Thank you very much.
Yeah, and then another thing, I was